to verify that this side equals this side, or vice versa. Now, I always want to go to the more complicated looking side, and so this side wins. This side is the more complicated looking side. Ooh. All right, so how can I start this? Well, I can't take the square root of those because they're not perfect squares, but I can do some manipulation of the fraction that's inside of it. Yeah? I don't know if it'll work, but I'm just going to try it. Let's see what happens. So we have this fraction. We have a 1 minus cosine theta up top and a 1 plus cosine theta on bottom. And I want to multiply the top and the bottom by the same thing, which I'm allowed to do because they're fractions, all inside of this crazy square root sign. Okay, what would you want to multiply the top and bottom by in order to change the look of this fraction? I want to manipulate it.
The inverse of the denominator?
Ooh, the inverse of the denominator is probably the best idea. Now, you could have said 1 minus cosine theta, or you could have said 1 plus cosine theta. But I'm choosing 1 minus cosine theta, and the reason why I'm choosing that is because I don't like having fractions. And if I like try to get rid of my denominator, things might look prettier later down the line. I don't know. Okay, so let's just try it and see what happens. Okay. All right, so first we got to go 1 times 1, which equals 1, and then 1 times negative cosine theta, which is negative cosine theta, and then negative cosine theta times 1, which is also negative cosine theta. So I'm just going to say I have 2 of those. And then a negative cosine theta times negative cosine theta, which is positive cosine squared theta. Did you guys catch all that?
Yeah.
All right, the bottom is the easy one. Yay. 1 minus cosine squared theta. Because when you multiply those, that gives you a difference of squares. It makes the multiplying process way more simple. Okay, that looks still kind of nasty. But now I have things I can do. Instead of square rooting the whole thing, I can square root the top and square root the bottom. Oh, do you guys see an identity? I almost missed this. This is sine squared theta. Do you guys know what the square root of sine squared theta is?
Sine theta.
Yeah, is that positive or is that negative? How do you know? No, it is. But we do have to say sine theta, and we have to put absolute value bars around it because we got to make sure that that's positive. So now let's look at the top. This guy right here can be factored, and it's actually a perfect square trinomial. And now I'm looking back, I'm going, dang, I shouldn't have multiplied these things out. I should have just wrote them out. I should have went 1 minus cosine theta squared. And then I could have just canceled the square root and the squared out. Oh, snap. And then look at that. Look at that. Isn't that what we got? Oh, dang. No, you didn't. No, you didn't. Yes, I did. Okay, so I got it. Yay, I win. And I started by being really confused and just thought, I'm going to manipulate the inside. And I got lucky. Sometimes you try something and you start getting nowhere. Like you can start getting something that looks nothing like the other side. If that's the case, you got to start over. Like scratch it out and start over. So whenever you square root something, you want it to be a positive number inside there. If it's not a positive number inside there,
that makes sense.
yeah. And see, the top I don't have to, because what is the greatest that cosine theta can be? What's the greatest number that cosine theta can be? When I look at its function, what is the greatest, the maximum number that cosine can be? 1. And so if I went 1 minus cosine theta, I will never get a negative on top. This number will never be negative. Okay, so that's what we got.